So we come to the bubble sort. The notes in the week are much more detailed, but what I'd like to do is talk through the logic of a bubble sort in terms of coding. We're going to break the sort down and look at some of the coding tricks you would have to do. You clearly would need to have some kind of condition at the beginning of any bubble sort method to make sure that you have more than one item in your list. I mean, that's absolutely critical, because if you only have one, there's nothing to sort. If you have less than one, there's nothing to sort. So that condition, if that condition isn't satisfied, then you'd have to just exit your bubble sort. You wouldn't proceed any further. So let's assume that you do have. And what we'll do is, as before, we'll draw a picture. So there's our list. There's your head, pointing to one, pointing to another. Let's just say 3 items. There's your tail. Okay. So that's our list we're going to look at. We're going to sort of put the numbers 3. Let's say it's holding 3 in there, 1 in there, and 2 in there. So we're going to discuss how the sort would work and what the logic of it is. The very first thing to say is that what you really need to be doing in your code is sort of starting here and then getting hold of the next one, checking them and comparing them, swapping them, right? And so on. The swap mechanism we'll have separate video for. And then theoretically, deciding what you do after you swap, what happens, and we'll discuss that. But what's really, really important is that if you ever write code like this, let's just call it temp, and you point it to any node, it could be any of the nodes. Let's say it pointed to the head, okay? It does not make a copy of the head and store it there, and this is absolutely critical. All the earlier videos I did about objects referencing is fundamental to the power of how you would write the bubble sort code. And the bubble sort code really does apply the concept of object referencing, address referencing, and all of that stuff. What you're doing in a line like that is you are taking the location, the address, and you're passing it into temp. So temp will now point to the same item. And the power of that is, if you change anything in the value inside that object, it will change it in the list. You don't have to remove it, insert it, or anything like that. This action simply gives you access to the item. The assignment operator assigns the location and basically points you to the same one. It's a very fundamental concept here, because so much of the mechanisms that you're using require that to work. So let's sort of work out how this would work. So you're going to, first of all, you'd like to get hold of the head. Okay, so there's your head. There's a bunch of things, and there's your tail. Okay, so you need to grab hold of that. But then if you're going to do a comparison, you need to ask the head for its next item and grab hold of that. So you grab hold of, say, temporary one, right? And you grab hold of the temporary next. And the basic idea is that in those pairs, that's where you do your comparison. Now we're going to try to sort it so it's low to high. And because our list, if you remember, if we go back to our list node is just simply storing an integer. So these are just integer values. So I'm going to just put a scenario in. I'm going to say that's 3, that's 1, that's 2. Okay, let's come back to the sheet so you can see, right? So what I need to then do is have a loop of some kind. I need to repeat stuff inside my code. First thing I need to do is compare them, the values. If this one is greater than that one, then I need to swap them. Right? And when I swap them, if I swap them, and we'll come to what the swap code would do, you'd need to pass them, the references, both into the swap. Then what I do is I restart my bubble sort. So that's the method I'm in. I'm in the bubble sort method, but then I re-invoke it. So the idea is that it goes all the way back to the beginning, and what you'll have is that those two have been swapped like that, and then you start again. You compare those two. You don't need to swap them. then you go to the next two. I've only got 3 here, right? So that's my next 2. Then I would swap them. If I swap them, I start again. So then I end up with 1, 2, 3. Compare those are absolutely fine. Go to the next bit, they're fine. It is sorted. The moment it's sorted, I don't need to swap. I don't need to rerun bubbleSort. I don't need to count how many times I do this. Using the mechanism of rerunning the method that I'm inside is called recursion. And it's an incredibly powerful mechanism to sort these values. So we'll come to the swap and the sort in a minute. Clearly, you need some kind of loop here, because if those two are in the right order, you need to then shift along to the next pair and then follow the same sequence. And if they're okay, then you shift to the next pair until you find a pair that you need to swap. The moment you swap, you restart the whole circuit, the whole cycle, sorry. And so it ends up bubbling, the lowest value bubbles that way and then should end up here through this sequence. That's the logic of it. Now, the notes give you much more detail and give you code suggestions. Please use them. And what we'll do is look at how swap works next.